So let's take a look. I know as you're sitting there, you're thinking to yourself, probably, I'm just guessing, that you want another formula, right? Okay, so it turns out there's two formulas. There's the velocity one with the radius, but there's also another concept here, and that's the concept of period. Okay, period is the time it takes to complete one revolution or one cycle. So for example, the period of Earth's rotation is close to 24 hours. It's actually 23 hours, 56 minutes, and 4 seconds. Okay, and then by the way, it changes slightly due to like the cloud cover and all sorts of stuff like that, right? And why that is, you can look up. There's a difference between a sidereal and a solar day, but I'm not going to get into it right now. Okay, the period of the second hand on your watch is 60 seconds. It takes 60 seconds to go around. The period of the long hand on a clock is 1 hour, right? The period of the shorter hand, the hour hand, is, well, I guess 12 hours for a 12-hour clock, right? Okay, so the period is the time to go around once, and radius is still radius, okay? Now, how do we get this formula? Where did it come from? Let me just show you, okay? We start with this, right? Acceleration is v squared over r, okay? And then let me introduce this idea, right? Velocity is just distance over time. Well, the distance around this circle is 2 pi r, right? Divided by, and the time to go around is t, the period, right? So the velocity, the tangential velocity, literally is just 2 pi r divided by t. So let's substitute that in for the velocity, right? So now we've got 2 pi r over t squared divided by r, right? Well, let's do some maths. Let's do some maths, kitty. Okay, so let's see. 2 squared is 4. Pi squared is pi squared. R squared is r squared over t squared divided by r. Okay, so this is, just look, I just squared everything inside the parentheses. That's legit. Okay, notice that the r cancels, and you end up with a formula that looks like this. Is 4 pi squared r not squared over t squared. Don't forget to square the t. Kids always forget to square the t. Or they'll not square the pi, or they'll square the r but not the pi. Okay, so just, always look that formula up. It's just a weird formula. We're not used to it. I think, anyway, there's other formulas that distract from it. Let's just take a look at this guy. Okay, a merry-go-round completes a revolution every 7.15 seconds. This is probably on a playground or something like that. It's spinning slowly. What is your centripetal acceleration if you are 3.52? So this is our r. That's our t, the time to go around, right? So our centripetal acceleration is 4 pi squared r over t squared, right? So that's going to be 4, the number pi squared, right, times, we are 3.52, right? Right, and then don't forget to divide by 7.15, and don't forget to square this thing, square it. Notice that the units here, since that's seconds and that's meters, is literally just meters over seconds squared, right, which is the acceleration. It's what we expect. Okay, I'm going to do this. I'm actually using my fraction, 4 pi squared times 3.52 divided by 7.15 squared. And I get that is 2.718255. And if I round it to like 3 digits, it's 2.72 meters per second squared. Alrighty. Yeah,